Good afternoon, everyone. Today, we'll be talking about rational functions and how to differentiate them. But first things first, what are rational functions? Well, in simple words, a rational function is any function that can be defined by a rational fraction, which is an algebraic fraction such that both the numerator and the denominator are polynomials.
In this video, we show you some examples on how to get the rational function from different rational equations. So, we're going to grab the following rational functions by hand by finding the following information.
In finding the vertical asymptote, we will equate the denominator to 0 and solve for the x. So our answer will be x is equal to 3. In finding the horizontal asymptote, let n be the degree of numerator and m be the degree of denominator. So our y is equal to 1. For the x-intercept, our guide to find that is let y is equal to 0. So our y is the f of x. So the equation will be 0 equals to x plus 3 over x minus 3. And then 0 multiplied by x minus 3, that will be 0. So 0 equals x plus 3. For our last step, we will transpose. So the answer will be x equal to negative 3. For the y-intercept, our guide is let x equal to 0. So it will become 0 plus 3 over 0 minus 3. And then, we will just divide our numerator and denominator, which is positive 3 divided by negative 3. So our answer is y equals to negative 1. For the table, we will just make a table like this. And then, we will put numbers above like this. So the problem here is, we will gonna find the values in y. So to find that, we will substitute x in our given into the given values above. So for the first given, we will substitute our x into negative 4 in our given f of x equals x plus 3 over x minus 3. So the outcome will be negative 4 plus 3 over negative 4 minus 3. And then we will gonna solve it. So the answer is negative 1 over negative 7. And then we will divide it. So the answer will be 0.14. And then we will put it in our table. So it will gonna look like this. To solve for the other values, you will just repeat the same procedure. Substitute the given numbers in x to find the values in y.
So for this problem, we will look for the x and y intercepts. To get the x-intercept, we will rely on our numerator. In this case, our numerator is 1. Since our numerator has no degree, automatically, our x-intercept is 0. Next, let's solve for the y-intercept. In this case, we have to base on our f of x, which is the given itself, 1 over 3x. Now we have to substitute the x into 0. Therefore, 1 over 3 times 0. The answer will be 0 because you can't divide 1 to 0. Therefore, the y-intercept is 0. Now that we both have the intercepts, let's solve for the vertical asymptote. For this, we have to get rid of the x from the 3x, or the denominator. In order to do that, we have to divide both sides by 3. So 3x over 3 cancel the like terms, so we're left with 0. Now, our x is equal to 0. Therefore, now let's move on to our horizontal asymptote. To get the horizontal asymptote, we have to get the degree of the numerator. In this case, our given 1 over 3x has no numerator. Therefore, there's no degree. On the other hand, our denominator has a variable with a degree. Since the equation is bottom-heavy, It means our horizontal asymptote is 0. If the denominator's degree is higher than the numerator's, automatically our horizontal asymptote is 0. For our table, we could just end it with 3 on the right and left side. So in this case, 1 over 3 times negative 3 is equal to negative 0.1. 1 over 3 times negative 2 is equal to negative 0.2. 1 over 3 times negative 1 is equal to negative 0.3. 1 over 3 times 0 is undefined. 1 over 3 times 1 is equal to 0.3. 1 over 3 times 2 is equal to 0.2. And 1 over 3 times 3 is equal to 0.1. Our graph here is decreasing.
In finding the vertical asymptote, we will equate the denominator to 0 and solve for the x. So our answer will be x equals negative 1. In finding the horizontal asymptote, let n be the degree of numerator and m be the degree of denominator. So our y equals 0. Intercept equals, the answer is none, because in our domain it is 0, so it will be none. For the y-intercept, our guide is let equals 0, so it will become 2 over 0 plus 1. And then, we will just divide our numerator and denominator, which is 2 over 1. So, our answer is y equals 2. For the table, we will just make a table like this. And then, we will put numbers above like this. The problem here is we will gonna find the values in y. So to find that, we will substitute x in our given into given values above. So for the first given is, we will substitute our x into negative 4 in our given f of x equals 2 over x plus 1. So the outcome will be 2 over negative 5 plus 1. And then, we will gonna solve it. So the answer is 2 over negative 4. And then we will divide it, so the answer will be negative 0.5. And then we will put it in our table. So it will gonna look like this. To solve for other values, we will just repeat the same procedure. Substitute the given numbers in x to find the values in y.